Size, how many cards you get?
5.
How big is this? And now we're going to figure out why in the world I never get on my first hand. Ooh, a royal flush. Because this is a lot. So do you have any? It's probably over $1 million.
So
In fact, it may be over $2 million.
the probability is 3.84 times 10 to the power minus 7.
Oh, what was that again?
3.84 times. Oh, the other answer I did. Okay, 2598 960.
I'm sad I haven't memorized. 2598960. It went 2.5 million ways, different ways you can get what?
This.
5 cards given to you from a deck of 52. So that's why this is very powerful and very helpful. Does that make sense?
So probability will be 1 over that, right?
Oh yeah, and if you want to extend this question, you're like, okay, then what's my chances like in probability? What's my probability? You have to write this down, but we're going on with this. Extend the question. You know, that's how many combinations pop. If you're like, what's the chances if I got just 5 random cards handed me? What's the chances that one right there would be your royal flush? That would go in the denominator, but Art, do you agree? How many ways could you get the royal flush? There are how many?
4.
There's 4 different ways. So this would be your odds. It's not likely, is it? We're saying this is the chances of getting a royal flush handed to you
In the first trial.
in just one trial. So everyone, from this day forward, would you do me a favor? It could be 10 years from now. If you play cards a lot and you get a royal flush on your first, will you email me so I can tell my other students? I mean, that would be pretty crazy, isn't that? Highly unlikely?
Yeah.
Yeah.
5-0.
Now, I once had I asked every class this. I once had a student email. But you know what? I questioned her. I said, were those cards truly random? Do you remember how many times you got to shuffle? 7 times. You got to shuffle these 7 times before they're truly random. So I wonder if they're really random. She was a student at University of Maryland playing cards with her friend. She was a senior. And she's like, oh my gosh, I got to email Professor Mestre. I got a royal flush. You know? I'm like, yeah, but were they really random? So I got 1 email on that. And that's in the past, 20 years or so. Hey, quick story. We'll do some problems. This happened yesterday. I was observing a class, and someone was flipping a coin. And they were just looking at, okay, coin flip, heads or tails. Is that binomial?
Yes.
Heads or tails, binomial, right everyone?
Mm-hmm.
It's a binomial experiment. Independent trials, it's either heads or tails. So the person did it 10 times. Flipped the coin, recorded the results. Recorded how many heads there were. You ready for this? How many heads do you think if you flipped it 10 times? What would be likely? Because there's a 50% chance of being heads, 50% chance of being tails. How many heads do you think would come up? Someone, what would be likely? They flip it 10 times.
So 0.5.
How many of those would be heads? 5 out of the 10, right? Around there, right? It doesn't have to be true. Isn't that likely though? You ready for this? This really happened. So I'm kind of like, whoa. This person flipped the coin. 9 out of 10 were heads.
Wow.
I watched it happen. Now everyone was in the careers building. It was a carpet. So you may argue, yeah, but when a coin falls on a carpet, maybe, it falls over. But this really happened. My question is, I want us to calculate the probability of that happening. All right? So I'm going to put it, I'll write it out clearly on the board. My question is, with, 10 trials, right? 10 trials. What's the probability of success that would be landing as a heads?
0.5.
In Autumn, that would have to be given to you, but I think you already know what it is. What would that be?
0.5.
0.5, right, Autumn, for being heads? All right. I want to know, what's the chances that you could get exactly 9 out of the 10 to be heads? 9 out of the 10. Now, when you agree that seems kind of unusual, let's see what the answer is. I mean, come on now. Flip it. 10, only one of them was tails? That doesn't seem likely, does it? Let's see what we get. So when I set this up, my probability of getting how many successes? 9 would be, all right, what's the end value? 10 choose 9. Probability of success?
0.5.
I'll put multiplication. 0.5 raised to the
9th power.
9th. Parentheses 1 minus 0.5 raised to the. You remember how to get this number? Oh, let me go back to Mia. I got to get this power now. I have to subtract these. Yep, n minus x, good.
1.
10 minus 1. feeling this is gonna be solved.
So the P is always gonna be 0.5, right? Because it's
Not always. I'll make sure the next problem it won't be 0.5. It's given to you though. I know it was with the boy girl, I know it was the heads tails, but I'm thinking, what if it's Southwest Airlines? And they tell us that the probability of success, that means on time. On time is 85% on time rate. That's the probability of it being on time. It will totally change, right? So Liz, I know the last two examples, the probability of success was 0.5. Don't worry, we'll get to some more today where the probability isn't 50%.
Well, I asked that because it's a binomial.
You got what, 9
So binomial, oh yeah, two things, but think about it like, think of a free throw shooter, if they're shooting a free throw, and it's like 80% free throw success rate. They make 80% of the free throws. It's still a binomial experiment. You go, why? They either make the basket or they what? They miss it. There you go. So that P, it'll be given to you. It'll be something they recorded like looking at the past 5 years. Maybe the Census Bureau came up with this probability. It's like, yeah, about this percent. It's around 80%. 80% chance. Yeah.
I have 0.009.
Anybody else get that?
Yeah.
Oh, like I get the head nod? Thank you. I wouldn't even have to go up to the screen. 0.00976. I mean, this is low, right, everyone? Now, if you want to go to 3 places, we can just go like this. That's around 0.010, right? That's small. Would you all say this is unusual? Remember, for our class, we're going to say, just as a standard, anything 5% or lower is unusual. Is this unusual?
Yep.
And I saw it happen. So I knew, I didn't know the odds, but when you bet, I quickly calculated them. I was like, man, what's that? You know, because I'm a math geek. Man, what's the odds of this happening? I was just observing the classroom. This happened in the class. Like, let me see the odds of that happening. You know, typical math geek, though. I was very curious about something like that. That was very unusual, right? Do it. We're saying do it 100 more times. It would only happen 1 out of 100 more times. Cool. Now, there are some cool buttons on your calculator. I encourage you all to use them. I encourage you to use them. That you might find this process facilitated. Because that's a lot, right? And somebody might, no, I can do it like this on a test. Fine, this is great. But there is a binomial probability distribution function on your calculator. And it's titled Binom PDF. Binom PDF. So, here's what you have to enter on your calculator. So, and this is for the TI 83, 84 model, whichever one has. Binom PDF, you're going to put the number of trials here. You're going to put the probability of success here. And then you're going to put the number of successes here. So Liz, just looking this over real quick, if you don't mind. Which one of these has to be like a decimal point and a value? Which one of the 3? The probability. So will everyone remember that? If you put in like a number like 1.2 here, that's higher than 100%. It'll tell you it's an error. This has to be 1.0 or less. Cool. Now where is it? So I'm going to hit the lights. Everyone, you're going to love this. At least I think it's easier than this. You don't have to use it, but I think it's easier. We'll facilitate this. We're going to calculate this, and we'll see if we get the same thing to you. So we're going to a new menu. We've never been here before. Look for vars, and look at what's above the vars. There's something called dist. D-I-S-T-R. It stands for distribution. All the distribution functions right here. So I'm going to hit second vars. So I'm going to hit second, then the vars. And I hold it up like this, you go, I can't see that. Well, I'll go to the poster. I'm going to hit that button, and then I'm going to hit the bars button. And it'll give me this distribution menu. So second bars will give me this list. I'm looking for Binom PDF. All right, boom, boom. It's a long list. Keep going, keep doing. Oh, there it is, it's 0. And I'm going to hit this. Now, who's got the old school 83 calculator? Kind of like me? All right. Like me, this is what I got. This is how it shows up. All right, see, Holland has the upgraded calculator. I'm going to talk about hers and others in the class in a second. So the first thing I have to put the n value. What's the number of trials?
10.
10. Put a comma. Oh, does everyone know where the comma is? It's above the 7. The comma's above the 7. All right, now, do you see it, Liz, above the 7?
Oh, yes, that's right.
Oh, cool. Now, this has to be this point something, right? It's a probability. Point what?
5.
And Liz, it won't always be 0.5, but in this case it is, comma, 9. Heck, if you don't even want to close out the parentheses, it still works. But a lot of you close out the parentheses, right? It will still work. And you're right, there it is. Pretty cool, huh? Who likes that? Do it. I'm serious. I love it. What's most important is we understand, we read the question, we know what we need to use. We know what they're asking. Oh, that's a binomial experiment, which I recognized in that classroom last night. I was like, oh, this is cool. It's a heads, tails, and they were doing all these trials, right? But there was a small chance that happening, huh? Cool.
Can I ask
So
you a
outstanding.
question?
Oh, go ahead.
Now, do you use binomial? Because I was doing something on the books, like they had that thing on the airline ticket. No, sorry, how fast the place will come.
Right.
Another one was the blood, like 7% O negative. So binomial is like you do on a sample, like a small size, because when you give you a big sample, just to see how accurate they are.
That's right. That's exactly what they do. And you know what's so cool about this, everyone? He just said small size, like small sample. There's no limit on this, like, oh, your sample size must be 30 or higher. We'll find things like that in this course later on. We could do this, like I said, with a sample of 10. It was 10 trials. This number of trials is like a sample size, right? But we're just looking at, like, how many of these repeated trials are there? There were 10 of them. But they are repeated trials, like trying to get the ball in the basket. This plane is arriving at BWI Airport. Yeah, yeah. It's just repeated trials, right? Over and over and over again, right? Cool. Hey, now I'm going to go back to Holland's calculator. Who's got the upgraded new model? All right, here's what you got to do. The first thing it says is, you go to that button, it says trials, right? That's the first thing listed. The thing right after that will have a P. This is after you go to that binomial PDF on that menu in the second disk. And then this thing will just say, I believe X. I'll look at Holland's calculator. Hey, let me know if you need to come back, Joe. I'll be glad to help you with it. So it went to, oh, that's all right. So I'm going to go to second disk. Make sure you hit binom PDF for binomial. Oh, the PDF stands for probability distribution function. And trials, P, oh, it says X value. And then afterward, it says paste. So when you hit paste, it's going to paste that up there for your screen. So how many trials were there? 10. What was this? 0.5. This was 9. And then you hit paste. It pastes that, and then you hit enter. Did it work? Yeah. Ah, cool. It's funny, you go, gosh, you got to hit one extra button with the paste, but what they're doing is, you may like this. What if a student on their next test forgets the order? Like, oh, is it XPN or is it XNP? With your calculator, you're going to remember that order. So please remember the order. It's the biggest numbers first, the N, the number of trials, then the probability, right? And then the X value is last. Good.
So in the older calculators, we need to do it exactly the way you just said.
Exactly. And hey, let's say you, let's say, Gary, Gary, let's say you blanked out on the order during the test. Like you're like, man, I got, start like a trial and error. Because you'll try to go, that didn't work. That didn't work. It won't work. If you put, this number has to be, you know, this one has to be at least as big as this, right? Isn't that usually going to be the biggest number? I say usually because they're not going to say probably a 10 out of 10. They may ask that. So that big number, see, if you accidentally had these mixed up, the calculator will say, hey, you got something wrong there. It'll give you a little error message. Cool. What's in the middle though always? The P, probably. Cool. All right, so let's do one. Hey, I'm going to do baskets. All right. This individual, everyone. All right. And in this particular problem, free throws. Someone's standing at a free throw line. They're trying to put the ball in the hoop. This person is a good foul shooter. Right? He makes 80% of his free throws. All right, so that's given to us. So what's this P?
0.8.
0.8. Oh, I love it. You see, 0.8. or 80%, but we're gonna raise the decimal, 0.8. All right, now, trials. Okay, they're gonna go over to the gym, everyone. They're gonna make 40 attempts at the basket. 40 attempts at the basket. All right, 40 attempts. So which number is that?
10.
So I'm gonna write that down and make 40 attempts at the basket. But at least right now we know this, and we know this. And you're all waiting for this X, right? It's coming up, don't worry. But I'm gonna start out, because you're gonna get in the textbook, you're gonna practice this tonight, tomorrow night, and they're gonna ask questions like this, all right? They're gonna say, explain why. Before you even start, you're gonna go letter A. Explain why this is a binomial experiment.
Cause you can miss it.
Binomial experiment. And we'll be brief, but we definitely got to hit on this concept of two outcomes, success and failure, right?
Yeah.
We got to mention that. And then we'll also indicate that these are independent trials. Now, if we're not sure, I just want you to write the word assume. Like, I'll assume they're independent trials. Because you might argue, like, I don't know if they're really independent, you know? Someone might, if they missed the first one, they might get better at their second attempt. So we'll assume they're independent trials.
So what's the question?
All right, in this particular problem, I haven't asked any probability question yet. So I just want to point out, someone's trying to make baskets in a free throw from the free throw line. They're going to take 40 attempts at the basket. They've got 80% success rate, right? Now and we'll get to those, I'm about to go, what's the probability they make? That's coming up. But before I even start, this concept of putting those balls in that hoop, let's talk about, can we explain why that would be a binomial experiment? And so Mia, two outcomes, right? They either miss it or they make it. And that's a great explanation. That's what you just said is a great explanation. So you say, either